This is the second video on a review of factoring, and in this video we're going to look at trinomials and other forms of polynomials that we can factor. So we'll be looking at factoring things that look like this. So let's get started. First things first, let's talk about what are trinomials. So these are polynomials with three terms. That's where the tri comes from. So these are things that look like this. So you can see that they have three terms. And a lot of times what we're going to be looking for is they have this like x squared and then an x and then just a plain number without the x. So this is kind of what we're going to focus on to start. And the method that we want to use here is what's known as the trial and error method. So let's take a look at the example. X squared plus 3x plus 2. So to factor this, what I want to use is a method known as trial and error. There's a lot of different ways that people teach how to factor things like this, but I'm a huge fan of trial and error for several reasons that I'll explain to you in a moment. So the idea behind trial and error, it's actually a very simple concept. It kind of works with the idea that, so for trinomials, they have kind of this standard form of how you factor them. And all you have to think about is how do you multiply to get the first term and how do you multiply to get the last term. So you kind of make this educated guess about how this should be factored, and then you see if you're right. So in this case, so to get to x squared, so what times what will make x squared? Well, in general, that's going to be x times x. X times x makes x squared. And then what do I multiply together to get to 2? Well, that would be 2 and 1. That's the only way that you can multiply two numbers together to get to 2. Now, this is kind of my educated guess. And then what I want to do is I want to multiply this back together to see if this actually gets me to this answer. So if it's been a while since you've multiplied, I'll kind of walk you through this. So you're going to take each term in here by each term over here. So first I'm going to take x times x. So that's going to be x squared. Then I'm going to take the x times the 1. So that's just going to be x. Then I'm going to take 2 times x. So that's 2x. And then finally, I'm going to take 2 times 1, so that's 2. So I multiplied everything together. Here's what I'm left with. If I collect my like terms, I get x squared plus 3x plus 2. And so look at that. I multiplied this together and I got back to that desired trinomial. So the idea behind trial and error is that a lot of factorizations will look like this. You have x plus a number and x plus a number, and then when you multiply it together, you want to get back to this. So the reason I like using this method actually is there's a few things. I know there's like algorithms and there's like AC method and there's all these different ways that you can do this. But I like this because it's very quick and it's a very simple set of steps. You don't have to remember an algorithm. You don't have to remember like all these other steps. And if you do this and you get quick with this, it also makes you just a lot more comfortable with the numbers. So anything that makes you more comfortable in working with numbers, I always think is kind of a stronger way to go. So this can be a very fast way to factor things. The only downside of it is that occasionally it can be a little bit frustrating. So you have to just learn to kind of sit with the frustration and make a little bit of an investment in this. And if you can do that, then it's probably going to pay off pretty big for you. So that's why I kind of push this. So what I want to do now is I want to just take a look at a couple more examples. We'll work through them together. So let's say now that I've got, how about x squared plus 7x plus 6? Okay, so let's go through this method again. So what I want to do is I want to set up the factorization. So I'm going to have one thing times another thing. So notice that once again, I'm starting with x squared. So the way that you usually get x squared with factoring is x times x. Now I just have to think about what two things multiply together to get to 6. Now in this case, we have a few options, and you might already know where this is going, but just hold on for a second. I just kind of want to walk you through the idea behind this. So let's say I'm looking at this 6, and what pops in my head is a 2 and a 3. So 2 times 3 make 6. Okay, so if I multiply this back out, so, and you could pause the video here just to multiply it together on your own if you want to. So this is x times x is x squared, x times 3 is 3x, 2 times x is 2x, and then 2 times 3 is 6. So if I multiply this all together, I get x squared plus 5x plus 6. So look at this. This is a problem, right? I have 5x here, and what I needed here was a 7x. So this is why we call this trial and error, because sometimes when you make guesses with this, you might not get the middle term right, and that's kind of what you're looking for. So part of what you want to do here is be a little bit quicker with figuring out what is that middle term. So I want to just talk to you about how you can multiply something like this in your head. So we know the general structure of how something like this multiplies, right? So x times x, that gets me to this x squared over here, so I'm good there. And then if I multiply the last two terms together, 2 times 3, I can see that that gets me the 6 here. So you just want to think about then, what do you multiply together that will ultimately get you to this middle term? Well, I will take x times 3, that's 3x, 2 times x, that's 2x. So I can see here I've got 3x plus 2x. So just by looking at this and knowing kind of the structure of how this multiplies together, I know that this isn't going to work. So that's kind of your goal when you're doing this. When you can figure out what the middle term is just by looking at it, this is why this can get very quick. So at first, you might have to keep multiplying this together to get comfortable with it, but as you keep doing this, you'll get faster with it. Now, what I want to do is I just want to X this out. I don't want to forget what attempt I made, but now I want to change what my guess is. So 2 and 3 didn't work. So instead, what other things multiply together to make 6? Well, 6 and 1. So now if I multiply this together, so check this out. I've got x times x, there's my x squared. I've got 6 times 1, there's my 6. And then I've got 6x plus 1x. So if I write that out, this is x squared plus 6x plus 1x plus 6. And that indeed gets me to x squared plus 7x plus 6. So this is kind of your goal with this, is if you can kind of get down to this, you'll go a lot faster and you'll feel more comfortable with the numbers, and you'll have a little bit more finesse with this. So let's try one more. So now let's do x squared plus 7x plus 12. So I'm going to have x times x to set this up, and then you can take a second here just to figure out what would you multiply to get to 12. Now, you might notice you have a few options here, right? You could do something like 6 and 2, but if I chose 6 and 2, what would that give me for my middle term? See if you can just do it in your head. You can pause the video if you need to. So if I chose this, this would give me a middle term of 8x, so this would not be right. This would actually leave me with x squared plus 8x plus 12, so this does not work. So that would be the wrong guess. The right guess would be 3 and 4. That's going to get me to 3x plus 4x, that's the 7x here. Now, what a lot of people think about when it's set up like this, they think about what two numbers multiply to 12 but add to 7. That's okay to think about it like this, but you want to remember also that you can multiply this all together to check this, and I will talk about why that is in a few minutes. So you want to just kind of keep in mind, you don't want to just think about it strictly in terms of what two things multiply to this and add to this. You want to also remember this is kind of the general structure of this, and like I said, I will explain why that's true in a few minutes. So now let's have you try some examples. So go ahead and pause the video here and just see if you can do these examples on your own, and hit play when you're ready. So for this example, so I've got the x and the x here. So if I use 5 and 2, that will get me to the 7x in the middle. Now just another note, it doesn't matter the order that you have these in. So if you had x plus 2 and x plus 5, that's totally fine. It's the same thing. Now for this other example, so now I have to keep in mind that this middle term is negative. So how can I have something negative here but something positive here? Well, what that tells you is that the two things that you're multiplying together, they must both be negative, right? That's the only way that you can get something positive here but negative here. So those two numbers are going to be -2 and -6. And so if you just work that all out, so you get x squared minus 2x minus 6x plus 12, so that gets you what you need. Okay, so let's try these two examples. Again, you can pause the video here. And so in this case now, I need something that's going to give me -6, but it will ultimately give me 1x, positive 1x in the middle. So what that tells me then is that one of these numbers has to be positive and one of them has to be negative. So in this case, this is going to be 3 and -2. So if you had this flip-flopped, if you had the 2 positive and the 3 negative, so just work that out on your own and you'll see that that doesn't totally work. So this also makes sense, right? So the bigger number has to be the positive one so that this will end up being positive, right? If I work this all out, I've got x squared, I can see my -6, and then I've got 3x minus 2x. That gets me to that positive 1x here. So you just kind of want to think through those details, and if you need to multiply it all together just to check your work, go ahead and do that. Now here, I've made a slight twist on what this looks like. So let's still use the trial and error method here and see if that still works. So to get to the first term, all I worry about is the first term to start, x times x, that will get me to the x squared. Now I have to think about how do I get to this -32y squared? What do I have to do in this case? Well, in this case, I just have to worry about thinking, how do I get to -32 squared? So two numbers that would do that for me would be -y and positive 4y. So y times y will get me to the y squared, and then -8 times positive 4 will get me to -32. So in this case now, if I multiply all of this together, so let's see, what do I get? I get x squared minus 8xy plus 4xy minus 32y squared, and hey, that does indeed get me to my desired answer. So again, like sometimes when you see extra letters and all these other things in here, that might kind of throw you off, and then you might not be sure what to do. So the reason that I like the trial and error method is that, again, it's very simple. So I know how to get to x squared. So if I know how to get to x squared, I should know how to get to y squared, right? It should just be an extension of the same idea. And I also know how to make, like, I know how to find numbers that would give me -32. So if I focus on the first term and the last term, and then I just kind of multiply everything together, I can see what I get, and then I can kind of update my guess based off of what happened here. So it's very good for troubleshooting. Again, I know it's a little bit trickier just in kind of getting used to it, but once you get used to it, it makes you a lot faster. Okay, so now let's keep going. Let's take a look at the example 2x squared plus 5x plus 3. This is a little bit different this time. So I can still use trial and error here, but now we've got to be careful. So for my first guess, so again, I have to just focus on the first and the last terms. I'm no longer making just x squared, now I'm making 2x squared. So how would I do that? Well, this would be 2x and this would be x, right? So if I multiply that together, 2x times x, that will definitely get me to 2x squared. Now I have to get to what two things multiply together to make 3. Well, that would be 3 and 1, right? So if I just write those in here, now let's multiply this together and see what we get. So if I multiply this together, I get 2x squared, I get 6x, I get x, and I get 3. And you'll notice an issue with this, right? This actually gives me 2x squared plus 7x plus 3. So what is the conclusion here? Can we actually factor this? Well, why was this 7x? What made this 7x? The reason this became 7x was because I bounced the 2x off of the 3, right? And that gave me this very big term here. So with having this be 2x squared now, that kind of throws a wrench in things, and it makes us have to be a little bit more careful with what numbers we're putting in here. So 2x plus 1 and x plus 3 doesn't work for this, but I can make a slight tweak to this to make this work. So I could actually just switch the 1 and the 3, And so look at what happens with that now. If I multiply this back together, I get 2x squared, 2x, 3x, 3x, and 3. And now that will actually get me to what I need. So this didn't work, but this did. The second attempt did. So if you don't have just a plain old x squared here, it kind of makes things a little bit trickier, but the idea behind the trial and error doesn't change. So now what I want you to do is pause the video and try this problem here and then hit play when you're ready. So for this one, so to get to 3x squared, I'm going to have 3x and x. And then to get to the 5, I'm going to have 1 and 5. So then it just becomes a matter of making sure that you have the right placement. And so if I set it up like this, so I'm going to get 3x squared, I'm going to get 15x, x, and 5, and so that'll get me to the right one. So sometimes people find it a little bit harder when it's like a number here, and that's okay. Like you kind of just have to practice this a little bit. Okay, so let's try this again. I've got the next two examples, so go ahead and hit pause and try them on your own. So for this one, so I'm going to have 7x and x, and then two numbers that will multiply to 12. Well, that'll be 3 and 4, and this is the only combination that will get you to that 31. So again, if I multiply this together, so I've got 7x squared, I get 28x, 3x, and 12. Now, if you chose something else, what you want to do is just kind of investigate what happened when you multiplied it together so that you can make an educated guess. And you want to think a little bit about what would happen if you chose different numbers, if you flip them around. So like I said, this requires a little bit of patience to figure this out. But the more you play around with this, the more you're going to get comfortable with messing around with the numbers. And that's a very powerful place to be. Okay, so this last one, so let's see, I have x and x. And then now you might notice an issue here, right? All I can do to make that 2 at the end is the 2 and the 1, and there's no way I can rearrange this to possibly get to 7. So this one was a trick one. The answer here is it's prime, actually. Okay, so let's move on to the next examples. So go ahead and pause and try these two on your own. Okay, so this one, if I factor this, this is going to be x plus 3 and x plus 3. Now, notice that this is just the same thing twice, so I could actually rewrite this as x plus 3 squared. And it just depends on the context. Sometimes you might want to have it written like this. Sometimes you might want to have it written like this. So you just want to recognize that these are two ways to write the same thing. Now for J, you may have noticed there is actually a GCF here. So I can factor that out. And then I can factor this as well. So this becomes 2 times x plus 4 times x plus 4. So just because this has a 2 here doesn't mean that you have to factor it like we did the other examples, right? Sometimes this, if you look at the whole thing, it might actually have a GCF. So you just want to pay attention. The next two examples I want to work through together. So I've got x squared minus 25. So rather than trying to tell you like a special formula to remember for this or anything like that, I just want to think about what does this actually mean. So x squared minus 25, that's really saying that we've got x squared plus 0x minus 25. And if you think about this, so what this means is I need to figure out how to have this middle term actually drop out, right? So if I think about this from a trial and error standpoint, so to get to x squared, I'm going to have x times x, but now I need to think about what two things would multiply to negative 25 but would add to 0. Well, that would be positive 5 and negative 5, right? So this type of problem, this is not like a trinomial, right, because it doesn't have 3 terms, but it has the same format as a trinomial. This is what's known as the difference of squares. And it has a very like standard form of this plus and minus relationship that you see here. So once you kind of get used to the pattern, you can factor a lot of things that look like this. So if I use that same idea here, what would this be? Maybe you want to pause the video and try it on your own. So this would be x plus 4 and x minus 4. And I should just note here, if you wrote x minus 4 and x plus 4, it's the same thing, right? But you need to have that plus and minus relationship. So I want to get you just really used to kind of playing around with this. So go ahead and pause the video and try the next 3 examples. So for m, this is going to be x minus 9 and x plus 9. And for n, this is going to be x plus 1 and x minus 1. Now, notice O is a little bit different, right? This is x squared plus 4. So are there 2 things that multiply to positive 4 but would add to 0? There's not, right? So there's no way that you could really write this. You can't write x minus 2 and x minus 2. If you wrote this out, what would you get? You would get x squared minus 4x plus 4. So that's not what we need. Also, if I tried to do x plus 2 and x plus 2, that's going to get me just x squared plus 4x plus 4. So that doesn't work either. So we have what's known as the difference of squares, but we don't have the sum of squares. So none of these work. This form is actually prime. That throws a lot of people off, so that's why I wanted to bring this up. Okay, so let's keep going with that pattern now. So the next ones are going to look a little bit different, but try to follow that same structure and pattern that you've seen so far. So go ahead and pause the video. So this is going to be x minus 6 and x plus 6. So now let me make a slight tweak to this and just add a y squared into this. So what would that become? Well, this will be now x minus 6y and x plus 6y. So we just tack that y on at the end. Now, what about this? How do I do this one? Well, it's actually going to be the same structure. Don't let that fraction throw you off. So instead of this being 6 now, it's going to be 1 over 6y and positive 1 over 6y. And when you multiply fractions together, right, you just multiply the tops together and the bottoms together, and bada bing, bada boom, you're done. All right, so let's try a couple more. Pause the video and try these. So this is going to be 3x minus 5y and 3x plus 5y. Now for this last one, so again, you just worry about the top and the bottom piece. So this is going to be 3 over 4x minus 5 over 9y, and then just the opposite of that, right? 3 over 4x plus 5 over 9y. So now let's switch gears to another type of example. So take a look at this problem. So in the previous problems, we all had squareds. This has a cube here, and so this is like one of the few formulas that I actually do use for factoring. So this actually follows what's known as the sum of cubes. So it's a sum, it has cubes. The sum of cubes formula looks like this. If I have a cubed plus b cubed, then the way that this gets factored is a plus b times a squared minus ab plus b squared. So I use this formula to help me factor this whole thing. So in looking at this now, I have to kind of line up, how does this kind of align with this formula? Well, the x cubed is in kind of the a cubed position, right? And the 27 is in the b cubed position. So if my a cubed in the formula now is going to be this x cubed, what is my a actually going to be? What does that mean that a is? A is just going to be x, okay? Now, if my b cubed, the 27, is in the place of the b cubed, what does that mean that just plain old b would be? How would you figure that out? Well, you'd figure out how would you take the cube root of this, right? So the cube root of 27 is just 3. So in this formula then, what I'm going to do is wherever I see an A, I'm going to replace it with an X. And wherever I see a B, I'm going to replace it with a 3. So now let's go ahead and do that. So this is going to become, so x cubed plus 27. This is going to be, now instead of this being a plus b, this is going to be x plus 3. So this is x plus 3. And then moving on, this is going to be x squared minus 3x plus 3 squared. So now I just have to simplify this. So this is going to be x plus 3 and then x squared minus 3x plus 9. Okay, and so that's how that would factor. So let's take a look at another example. Now I've got x cubed minus 8. So this is what's known as the difference of cubes. So you might want to write that formula down as well. So this is going to look like this. A cubed minus b cubed is going to be equal to a minus b times a squared plus ab plus b squared. So you're going to want to find some way to kind of memorize those two formulas and keep them straight. You might want to have them kind of written down together, and then maybe practice them a few times because they're very handy and they can come up from time to time. Now, as far as approaching this problem, it's very similar to the last one. This is going to be what's in the place of my a cubed, and here's what's in place of my b cubed. So once again, I have to figure out if what's in the place of my a cubed is this x cubed. What does that mean that my a actually is? That would just be x. Now, if my b cubed, what's in the place of my b cubed is an 8, what would that mean that b actually is? Well, that would just be 2. So now in this formula, where I see an a, I'm going to replace it with x, and where I see a b, I'm going to replace it with 2. So maybe you want to pause the video here and now just see if you can kind of fill that part in. So the answer here then is going to be x minus 2 times x squared plus 2x plus 2 squared. So all of this, the final answer is going to be x minus 2 times x squared plus 2x plus 4. Okay, so that's kind of the idea behind that. So now what I want you to do is try that on your own. So go ahead and pause the video here and work these out. So this one's going to factor then as x plus 5 times x squared minus 5x plus 25. And then this next one, so this is going to factor as 3x minus 1, and then this is going to be 3x squared plus, this is 3x times 1 plus 1 squared, right? So I'm just kind of filling in those pieces. So if I were to simplify all of this, this would become 3x minus 1 times 9x squared plus 3x plus 1. And so that would be the final answer. Okay, so let's try that again now with these next examples. So let's go ahead and do the first one. So this is going to be 5x plus 4y, and then this will be 25x squared plus 20xy plus 16y squared. And now for this last one, just to keep you on your toes, so this will be 3 over 5x plus 2yz times, so this will be 3 over 5, oops, I just realized in the last one, sorry, that should have been a minus. Okay, and so then going back to this one, so this is going to be 3 over 5x minus 3 over 5x times 2yz plus 2yz squared. So now you just have to simplify all of that. So there's kind of a lot going on with this one, but this is going to be 3 over 5x plus 2yz. Oops, and this should have been squared. So this is going to be 9 over 25x squared minus 6 over 5 xyz plus 4y squared z squared. And so that's the final answer with that one. So apologies for those sign errors, but that's kind of the idea then behind working with the sum and difference of cubes. So you kind of just got to have that formula memorized and then just kind of work it out from there. So sometimes you might want to write out extra steps just to work that out. But that concludes kind of the review of factoring. So that's kind of everything that you need to know. Good job.